Finally, for the last section of the talk is compiling VASP for Perlmutter. This section will be useful for you if you would like to build your own version of VASP. And the workflow for this is fairly simple on Perlmutter. What you start doing is you obtain the source archive, or the VASP TGZ file, from your VASP vendor. And if you have this file, then you can upload this to Perlmutter. And then you start by unpacking the file using the tart command. And then you copy a makefile.include into the directory containing your VASP, your unpacked archive. From here, the build process is fairly simple. You can either build for GPU or CPU, and the builds for the two different architectures have very similar steps. For a GPU build, you want to, in either case, you want to load the NVIDIA programming environment, and the module reset command that I show at the top is just to purge any other things that might be in your environment that might conflict with the environment used to build VASP. So I highly recommend using module reset before starting this. And after loading NVIDIA environment, you load create HDF5 and create FFTW, which are needed to build VASP. Then if you're trying to make a GPU build, there is a patch to this one source file that is needed in VASP 6 versions earlier than 6.5, which is needed to use MPISH, which is what is implemented, the MPI implementation on Perlmutter. If you're using VASP 6.5, if you're building VASP 6.5 or higher, then you don't need this patch at all. If you're building for CPUs, then the steps are fairly similar, except instead of loading this nickel module for GPU communication, you're going to load the CPU module and then the Intel Mix module if you want to link to MKL, which is recommended for performance. Once you've loaded all of the modules, then you can just type make std ncl gam, and then you'll build all three executables of VASP, and you'll have your VASP build ready to use. If you're modifying the source of the VASP, then you just complete this entire workflow and then modify the source files right before issuing the make command. And then you should be able to build your system with the options that you need. The trickiest and most important thing to look at when making a VASP build is the makefile include. Now, if you want to look at the makefile include used for an existing NERSC build, then the NERSC modules have these available, as I mentioned earlier. And so you can find a makefile include for a given version of VASP that's installed by looking at the makefile include path for that particular module. And then you can copy this to your own folder and modify it as you need. Now, the makefile.includes that are on Perlmutter included in the VASP modules are specific to the NVIDIA programming environment. If you would like to build with either Intel or GNU or some other programming environment, then you need a different makefile include that's specific to that environment. And so if you want to find samples for a different compiler, then if you can start by looking at the VASP wiki, or there's a page on makefile include that you can use to get examples, and then you can copy examples from that folder and then modify those, which they usually require a little bit of modification before they'll work on Perlmutter. The other thing is, if you have another compiler that you like to use, then it is possible to build a makefile include for that, but it may require significant effort. So I mainly recommend using one of the programming environments that's well-defined on Perlmutter that has a PRGENV associated with it in the module environment. Finally, I just want to call attention to some items that are in the makefile.include that may be of interest. The first thing is that there are many pre-compiler options that you can set, and the majority of these are options that are set to improve performance when running on parallel architecture. Some that are of interest to you, that might be interest to you as a user if you're making a build, are the -d OpenMP, which is used to build with OpenMP parallelism. And then also if you're building for GPUs, then you'll want to add -d OpenACC, and then also -d use NCCL to link to the nickel library for communication between GPUs. The other thing is if you're using plugins such as Wayne90 or DFTD4 or any other plugin, many of these are enabled by precompiler options, and so you want to add these in the precompiler section. Another flag that I recommend putting in is the deprofiling flag, which is used for printing out the timings. And even though adding this incurs a small performance penalty in running the job, I highly recommend it because it can be used to troubleshoot when things go wrong with the performance of your job. The other thing I'll mention on this slide is that if you load a programming environment on NERSC, then the compiler is usually wrapped so that if you call the compiler using FTN, then FTN will default to either NVIDIA Fortran or GNU Fortran or iFort, depending on which programming environment you have loaded. So what you can do is you can write this so that you call FTN, and then loading the correct programming environment will automatically give you the correct parallel compiler to use. The last thing to mention is later on in the makefile.include are a few things that you'll need to add if you are including certain plugins, and that is that you'll want to include links to their libraries so that when you build VASP, the linker can find them. So when building for GPUs, I recommend always using nickel. So you'll want to load the nickel module and declare it isPath. And then if you're building for CPUs and you want to use the Intel MKL or the FFT lab utilities, then these can be uncommented out of the NERSC makefile.includes to build with these as well. And then finally, if you have third-party codes such as Wayne or 90 that you want to link to, then the very last part of the makefile.include allows you to declare the paths to those libraries. And so those have to be set in order to link to the libraries. And you can link to the libraries that are built by NERSC if you're building with the same compiler that NERSC uses, which in this case is the NVIDIA compiler. But if you are building with a different compiler, then you'll want to build your own plugins and then link to the libraries that you built in your VASP build.